Now, following the two presentations, we will have a panel discussion. I would now like to ask for the moderator, Professor Kamihigashi.
Okay, so can we start now? Okay, I would like to thank, first of all, I would like to thank both speakers, Khalid Mosalam and Atsushi Izuka, for the wonderful presentations. We have decided to go by first name, so I'll try to call you both by first name from now on. But I'm not really sure if we can keep it that way to the end, because in Japan we usually go by last name, especially among last names. Anyway, my name is Takashi Kamihigashi. I'm the moderator of this panel discussion. I'm also the director of the Center for Computational Social Science in Kobe University. I'm actually an economic theorist who also works on computational social science. But recently, more and more of my activities are related to computational social science. Currently, Atsushi, the last speaker, is the leader of the research group behind this whole Mirai Bosai symposium, and I'm scheduled to take over in this coming April. Today, March 11th, is a very special day.
Yeah.
11 years ago, the Great East Earthquake, the Great East Japan earthquake happened. People in Japan, as well as in California, feel the pain of past disasters, including the major earthquake in Kobe and its surrounding areas in 1995. We also feel the pain of other people who are in the middle of a disaster, such as what's currently happening in Ukraine. As an economist or as a social scientist, it's hard to say who's right or who's wrong. But one thing I'm sure of is that our thoughts and hearts are with the victims, the people who are suffering from disasters that happen every day, and the people who are afraid of future disasters. Coming back to the presentations, they were both related to preparing for future disasters. And there was so much information, and I cannot pretend to understand everything. Some of it was quite technical. So I might interrupt for clarification here and there. In any case, I would like to start this discussion by asking both speakers to ask questions and comment on each other's presentation and move on to an open discussion later on. Okay, so Khalid, would you begin with your questions and comments on Atsushi's presentation? And if you have anything to add to your own presentation, you can go ahead and do it here too, please.
Thank you very much. It's my pleasure to be here, and I am very happy to listen to Atsushi's presentation. I learned quite a bit. The way I see his presentation is you are looking at a very big problem. You're looking at a digital twin for the entire city that involve all its components. My presentation focused on a small aspect of what Professor Izuka is trying to solve, which is only the transportation network, and particularly only a small sample of bridges. And this is very important these days where we have a lot of opportunities to obtain data from the built environment using sensing technology on all level, point-wise, on a global scale, using GPS and satellite imagery and so on. So my question to Professor Izuka, one thing we struggle with when we do our work related to bridges is in arriving to a decision making that is useful for engineers and practitioners. How do we bring, and it has something also to do with what you said, Takashi, about bringing the technical knowledge to a useful decision making to the stakeholders, whether it is the public or the engineers or the maintenance crew. So my question to you, Atsushi, have you dealt with this dilemma? How we handle going from the technical to the actual implementation and the use of our work in the field?
Thank you very much. Let me summarize my presentation. And honestly speaking, I completely agree with your opinion. You emphasize the importance of decision-making by stakeholders. In my presentation, I touch mainly the technical development technologies around the DX, digital transformation. So I did not mention about decision-making. Of course, that is very important. But to make a decision, sufficient and correct and appropriate information should be supplied, should be given to the stakeholders who have to make a decision. To encourage this trend, my presentation is a nice, shows a nice direction to reach the goal. I agree with your opinion. That is a very, you point out a very important issues, I think.
And I actually have a question for Khalid. So what is the biggest challenge from bringing your own technology to implementation? So that was your question to Atsushi's presentation, but it's the same question for you.
Yes, sure. That's also a very good question. And I can pinpoint two challenges. The first one is in the on the front of the work we did is how to obtain the data in real time and also to handle the data volume. And Professor Izuka also alluded to that, is the amount of data is huge. So how we deal with that large body of data in an efficient way and make sure the data is accurate, representative of the measurements, the sensors are working properly, and be able to do all that as much as we can in real time. So that's the beginning challenge. The end challenge is what I ask Atsushi is, how do we package our findings in a way that is appreciated by stakeholders and engineers? And in our side, it was very helpful to work with California Department of Transportation, understand how do you do the maintenance, how do you do the first responding. And once we understood that, we started figuring out how can we bring our technology, our engineering calculations to that type of terminology that they understand and appreciate and can respond to. So I would say these are the two biggest challenges that we faced in our work.
I think, oh, sorry.
Go ahead, please go ahead.
I think the before you are pointing out the point you pointed out issue, we have to, what to say? I believe the most important thing is how can I implement our technology into the various kind of sectors, such as private sector. The one is academic side, and others. Then they will provide sufficient and appropriate and correct information to the stakeholder who have to make a decision. So that the first thing is how can I implement this kind of technology to societies? This is the first priority we have to achieve, I believe.
Yeah, I totally agree. And I think this is driven by the fact you are dealing with a much bigger problem where you look at things on a city scale, where you have to deal with system of systems. In my case, I have a simpler problem that I only deal with a few bridges and only transportation network. So I only deal with one agency in my case, which is the California Department of Transportation. But I definitely see the challenge when we work with multiple infrastructure, especially when we look at human infrastructure interaction, as you presented in your very nice talk. Yeah.
I think that Atsushi is still mainly struggling with the first challenge Khalid mentioned. So Khalid is also struggling with the second challenge. And so do you have any difficulty in convincing your stakeholders what should be done and what can be done and things like that?
Sorry? Is that to me or to
yeah,
Professor?
Sure, yeah, Khalid, I mean.
No, because our stakeholder is mainly, as I mentioned, California Department of Transportation, and they are on board of the importance of monitoring key bridges. But I would say, yes, there is certainly some difficulty in trying to monitor all the state highway assets, because it's so many bridges, many tunnels, the different, the 4 levels I mentioned in the beginning of my talk. But in terms of doing this monitoring and developing the digital twins for key elements of the network, there is no difficulty in convincing the stakeholder of that importance and need, because such elements are already flagged of being a priority. And the other thing is in the era we live in it, where we are surrounded with all these Internet of Things, all the sensors we have, it's very easy to convince a stakeholder of the importance of making use of these monitoring systems. We as human beings, we have a lot of wearable devices that monitor all our organs. So we should do the same thing for our built environment as well.
Thank you. And Atsushi, what is your current impression about communicating with possible stakeholders?
Yes, I got what to say, the good impression from the Khalid's presentation. He emphasized the importance of monitoring and the simulation, combining monitoring and the simulation. That means that will be very helpful to the people and who behave at the event of a disaster. But I did not mention on the monitoring in my presentation. This is quite different from my presentation. again, he pointed out the importance of monitoring and also the combination of it with simulations. This is a very good point, and this is a very, what to say, understandable, but provide understandable and comprehensive evidence to the stakeholders. That is encourage proper communication between the engineers and decision makers. Again, key, I think a key is monitoring in the ordinary time and a combination of monitoring and simulation. Thank you very much.
And Atsushi, do you also have questions and comments on mostly questions, I mean, on Khalid's presentation? Do you want something?
His presentation is very understandable to me, and I got a very deep impression from his presentation. And also that he emphasized the importance again, let me point out the importance of monitoring and the simulation and the combination in between. That is quite important to provide reliable information to people. And again, he mentioned about the bridge operation action. This is a kind of a manual when we had earthquake at the event of earthquake. That is a very nice, what to say, strategy. How can I respond against the unexpected event such as earthquake? In our country, we have to prepare this kind of operation action in the stakeholders such as government and local government, so on. This is my private opinion obtained from his presentation.
Do you have any response, Khalid?
Well, thank you for the comments. One thing I can add also to what Atsushi mentioned, which one common thing between California and Japan is the occurrence of many earthquakes.
That's right.
And these earthquakes, not all of them are damaging earthquakes. Fortunately, some of them, because of the built environment in Japan and in US, is of good quality, or at least we hope so. Mm-hmm. And we have good codes and good engineering practice. So we are hopeful that in many of these events, our infrastructure, buildings, bridges will perform well. But we need a way of telling the engineers that this bridge is still in good shape to remain operational, such that all the things that Professor Izuka mentioned related to the society are not disrupted. Because if for every event we have to close the bridge to go and do inspection, there will be disruption to the way we live. There will be difficulty in getting ambulances to the hospitals. And so fortunately, many of these events are not going to lead to damage, but the delays in going and inspecting bridges can lead to temporary closure of the bridge, and then it will affect the functioning of the society. So this is what we try to do by what Professor Izuka mentioned, is to combine data from monitoring system with simulation so we can arrive to this decision, hopefully in most part that the bridge is sound and it can remain functioning. In an event of a major earthquake, we can also conclude that, yes, the bridge is imposing risk now, and we should close it until further action is taken. So that's That's in addition to what Atsushi mentioned. Yeah.
I think you mean you mentioned the importance of providing information, not only the risk, but also the safety.
Yes.
To the people at the event of earthquake. That's the important. Right. Yes, I agree. Yes. Throughout the, yeah, sorry, go ahead.
And avoiding unnecessary disruption if it is not needed.
That's right. I think throughout our entire city simulation technology, I believe we can provide that kind of safety information to the people at the event of earthquake. Not at the event of earthquake, in advance, before earthquake. Then the people can prepare by themselves what should we do at the event of earthquake. This is quite important to save the lives and the damage against the disaster, I believe. Thank you.
Probably it would be ideal to do something like what Khalid is doing to the whole whole city scale simulation, or what Atsushi is doing. I'm not sure if I'm making sense, but do you think it's Khalid? Do you think it's possible to do something like that to a city scale, monitor everything and analyze? Probably in the near future or far future, I'm not sure.
Well, already you see the effort of Atsushi, and this is definitely a step in the right direction, as he pointed out. It will require more work because it's a big problem, and cities are very complicated systems. But he already started this work, and with the support from private sector, as he alluded to, and also the government in terms of monitoring, simulation, data, sharing the data, because sometimes it's hard even to get the data itself because different agencies kind of,
That's right. That's very
issues. Yes. So with that cooperation between agencies and, of course, the academia and the practitioners, it can happen. I don't know if it can happen in the near future. Of course, some cities are more advanced in terms of maintaining the data and sharing the data. Maybe other cities, that's going to take longer time. But we have to start, and hopefully with the digital era we live in and digital revolution, that will continue, and eventually we have digital twin of at least the major cities who are very vulnerable to natural hazards.
Thank you. What about you, Atsushi? So do you think it's possible to bring real-time monitoring and decision-making to the whole city simulation technology too?
Yeah, that is a quite right direction we have to do in the future, from now. But it is, I think it is not easy to achieve all. Then I would like to take a step by step. And actually, recent years, many kinds of data, not only the infrastructure data, but also the many kinds of data available. They are available in the cloud, but they are completely different in between. One is a PDF, the other is XML, and the format and specification is quite different. So that is a very difficult, that is a quite big difficulty to use these data. We have to convert automatically, and we have to extract necessary information from, and first of all, we have to find out where is our necessary data is. That is a very difficult to find out. Then we need much more innovation in this kind of a field. So we are civil engineer. The Khalid is also the professor in the Department of Civil Engineers. So we have to do research on the activity in this direction.
Mhm.
Then we can, what you say, reach the goal. We can get very nice consensus among people, and we can guide the people when the earthquake occurred and so on. That is nothing else but a safety assessment and safety management. Which is a future style. Sorry, that is I'm sorry, I'm not familiar with the English conversation, so my poor English ability cannot express what I want to say correctly, I'm afraid. But probably what I want to say is, Khalid, kindly understand what I want to say. I want to transfer.
Yeah, absolutely. I totally agree with you that civil engineering applications is the most important generator of big data. But we as civil engineers, by training, we do not do research as much as we should on big data. And I guess your point is we have to do more work on big data, make sure we identify where important data coming from, data standards, and we should work with our colleagues on data science and computer science on these issues, because they also...
And also that we need a support from the economist.
Absolutely.
Like Professor Kamihigashi.
Yes.
We need help and support to realize our dream.
I think your last point is probably one of the most important, because the only way to convince the stakeholders of the importance of monitoring is to show the economical benefits of avoiding significant downtime, monetary losses, and of course, life safety. And we need economists to guide us and help us, at least in this life cycle cost analysis, and what are the benefits of having monitoring and digital twin on a city scale.
And also that kind of such as a life cycle cost should be understandable to the economist. So that means we need some implementation and translation of our peer technologies to make familiar with the economist, to the economist.
Yes.
Mm. Thank you very much.
Do you want to close the discussion, or?
Yeah, I'm now not hungry. I'm full on my stock. We enjoyed the discussion with Professor Mosalam, and he pointed out very important things. One is monitoring and simulation combination. The other is operation action. That is very impressive to me. And also that his comment on our activity is quite helpful, and And we considered deeply, and we try to specify what should we do from now. Thank you very much.
And
Thank
Khalid,
you.
yeah.
Yeah, thank you very much. I am looking forward to learning more about the research in your group in Kobe, and to continue the collaboration between Kobe University and the Pacific Earthquake Engineering Research Center. That's very beneficial for us to see what our friends in Japan and Kobe in particular are doing, and we exchange ideas. We share similar problems of natural hazards, and
That's
we
right.
should work together in solving these problems for the interest of our mutual societies.
That's right. And also I want to appreciate the moderation by Professor Kamihigashi. Very helpful and encouraged our discussion. Thank you very much.
Well, thank you.
For his effort.
Yes.
Okay, so
I agree.
So we can see that both of you are moving in the same direction, and
yes,
I can see various possibilities for future collaboration, and we should continue our efforts to work together.
Yes.
I hope so.
Yeah.
That will be our pleasure. Yes.
All right. Thank you very much.